Hello dear students, now solve question 7 is about our chapter 2. As the circus performs a juggler, is throwing two spinning clubs. Okay, one of the clubs is heavier than the other. We have two clubs. One club is heavier than another, or we can say one club is lighter than the other. Okay, which of the following statement is correct or is true? The smaller club is likely to have a larger moment of inertia. It's incorrect, because moment of inertia is directly proportional with the mass. This option, this is written, the smaller club is likely to have a slight or a lighter than moment of inertia to the heavier club. Option A is not correct. B, the ends of each club will trace out parabolas as the club is thrown. It's incorrect. The center of mass of each club will trace out a parabolic as the club is thrown. Selection C is correct. Why? Because the correct answer of this question, we know that when we have a stick is rotated in air, each end of the stick will trace about center of mass. Okay. But the center of mass of the stick will trace a parabolic, will trace. So we can say it has or rotated is on a parabolic, okay, path. Then we can write selection A is correct. D, both A and B are correct. It's incorrect. Just option C is correct. Thank you. Hello dear students, I am M.اسماعیل, I'm a physics teacher. I will solve some ministerial questions about chapter 3. Chapter 3 is about vibration and waves. At the beginnings, I will solve question 1. This question is about ministerial question to the year 2025 first round. Question 1. What's the restoring force of the mass spring system? What's the restoring force of the mass spring system when it vibrates in a simple harmonic motion? A, elastic force of spring. B, weight. C, frictional force. D, both B and C are correct. We know that we have two systems in simple harmonic motion: pendulum system and mass spring system. In mass spring system, the elastic force is the restoring force is what? The restoring force in mass system spring is only or is just elastic force of spring. So the correct answer is what? Option A. Elastic force becomes restoring force in mass spring system. Okay. After that, I will solve question 2. Which of the following does not affect the period of the mass spring system? Which of the following does not affect of the period of mass spring system? We know that in spring mass system we have period and frequency. The period is not independent on the amplitude and what? And free full acceleration. Which of the following is not or does not affect? Section A, mass is affected. Spring constant is affected. Why? Because you have to write the main rule of period to mass spring system equals to 2 pi m over k. K is the constant, spring is dependent. So the period is dependent on the mass. But we know that period in mass spring system is not independent on the amplitude. We have. Why? Because amplitude is the absence, or it's not has in rule of the period. Okay. Mass answering system, it's incorrect. Amplitude of vibration is correct. We can say or we can write the option D or the selection D is correct because we know that period in mass spring system is not independent on the what? On the amplitude and the free fall acceleration. Thank you. Hello dear students, now I solve another question about of chapter 3. Question 3. If the frequency of an object is 5 Hz, if the frequency of an object is what? Okay. Is 5 Hz. F, okay, equals to 5 Hz. Okay. Calculate its period. Calculate its period. We have to find period of the same system. We know that T is always equals to 1 over what? 1 over F. So when we have its constant, what's amount of F equals to 5? 1 over 5 equals to 0.2. What's the mean unit of T equals to second? The correct answer is 0.2 second. A 0.5, B 10 second, C 20 second, D 0.2 second. We can select option D. Thank you. Hello dear students, I'm م.اسماعیل, a physics teacher at Typical English School. I will solve another question ministerial question to the year 2025 first round. This question 4, is about of chapter 3. A tuning fork produces a sound with frequency of 460 Hz. This is a frequency of the source is what? 460 Hz. This amount of frequency with a wavelength in air of 0.5075 meter. This is amount wavelength of equals to 0.75 watt meter. What value does this give for the speed of sound? Or the unknown part of this question is speed of sound. We have to find V. Okay. According to the rule of speed of sound, we know that V equals to wavelength times F. Wavelength we have equals to 0.75 times. So the frequency of the source is 460 Hertz. V equals to 345 meter per second. Then we can select the correct answer is 345 meter per second. Option A is 340. Option B 345 meter per second. So C 350 meter per second. D 355 meter per second. We can select option what? Option D. Option B is correct answer. Thank you. Hello dear students, I will solve another question about chapter 3. Question 5. The figure shows a standing wave. This figure expresses or indicates to a standing wave. We know that this figure consists of 3 antinodes and 4 nodes. wave on a vibrating string, if the wavelength is 1.5 meter, the wavelength of the wave equals to 1.5 meter. This is the wavelength. Okay. What is the length of the string? The length of the string is unknown part of this question. Dear students, you have to now separate between length of the string and the wavelength will produced by the standing wave. Okay, at the beginning we have to write the main rule of standing wave. We know that lambda equals to 2L over what? I. I indicates or is the antinode, number of antinode of the standing wave. Number of antinode equal to what? 3. Okay. When you want to find L or length of the string equals to 2 is transferred to numerator. Lambda times what? Times number of antinodes. Lambda we have. What's the amount of lambda? 1.5 meter times 3 over 2. 3 times 1.5 equal to what? 4.5. Divide by 2 equals to 2.25 what? Meter. And the correct answer is 2.25 meter. This is the length of the string that according to this figure. Look at the option A, it's incorrect, 1.5. It's incorrect. C, it's incorrect. Option D is correct. Why? Because D, it's written 2.25 meter. The correct answer is option D. Thank you. Hello dear student, today I solve another question of chapter 3 for the 12th grade. This question is a ministerial question to the year of 2025 first round. Question 6. A pendulum bob hangs from a standing with moves with a simple harmonic motion. If the pendulum's length is 1 meter, if the pendulum's length is what? Is 1 meter. The length of the pendulum the length of the pendulum is what? 1 meter. Okay. And the free fall acceleration, Ag equals to 9.8 meter per second to the power 2. How many complete oscillations does the pendulum make in 2 minutes? How many revolutions does the pendulum make in 2 minutes? Number of revolution, we have to find it, but in time interval, 2 minutes. We have to convert this minutes to second and equals to 2 times 60 equals to 120 seconds. Okay. At the beginning, we have to find period of the system. After that, we have to find frequency of the system. After that, we can find what number of revolution. Okay. T or period equals to 2 pi L over A sub G. This rule is about of the pendulum when it rotates in a simple harmonic motion. Okay. 2 pi we have. The length of the pendulum is 1 meter. Free fall acceleration 9.8, and we get to the time is equals to in second. After finding period, we can find frequency, or we have to find frequency. Frequency equals to 1 over T equals to 1 over. The amount of T is, we found it. After finding frequency, we have frequency equals to number of revolution over time interval. Okay. Number of revolution equals to frequency time interval. Do you understand? Okay. So the number of revolution equals to frequency times 100. We found frequency and equals to 60 revolution. Section A, 160 rev, it's incorrect. B is correct. Why? Because B is right in 60 revolution. The correct answer is option B. Thank you.